Hypothalamus Artificial Intelligence, HI. It presents companies in the process of digital transformation, its offer of professional services and the supply of algorithms of highly complex multi-problem mathematical models. These services are called. To provide these services, HI is supported by its business partners, GAMS, IBM and TD SYNNEX, all of which are producers of artificial intelligence technologies. HI is a company at the forefront of high-performance artificial intelligence. Oil and gas industries enterprise-wide optimization. Oil pipeline real-time optimization. Oil supply chain optimization. The oil and gas supply chain is made up of 4 links: upstream, midstream, downstream and retail. The links are connected by multimodal transport networks. The oil industry includes global processes of exploration, extraction, refining, transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. Optimization solutions in the transport chain of petroleum products can be classified by their hierarchy: strategic, tactics, and operating. Several of these applications will be discussed below. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of High Oil AWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. The current computational power allows to model detailed the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. All models developed by HI, to support decisions in the oil industry, are interconnected trough and information system. In this way, the construction of artificial hypothalamus is a question of joining the equations that make up the different models. Oil transport systems optimization corresponds to a general model, common to all types of oil products, raw, refined, natural gas and biomass, which represents the process for a specific system, including particular equations when this is required. It considers 2 types of transport modes: pipes and multimodal vehicle, like vessels, barges, train tanks, and/or trucks tanks. The table presents a summary of the mathematical models developed by HI for oil and gas transport optimization. Pipelines planning and scheduling. The problem of optimization of pipelines involves safe, reliable and economical operation, in which, for each moment of the planning period, the flows, pressures and configurations of the pumping stations must be determined, according to the different types of products that must be transported through the pipeline network. The goal of the operation moves between 2 criteria. Minimize energy consumption, environmental criteria, which is important to preserve the sustainability of the planet. Minimize the cost of energy, economic criteria, which is important in energy markets where rates change throughout the day. On the other hand, the technical operating conditions, hydraulic conditions along the pipelines and at the pumping stations, must be respected regarding the flow of multiple, different potholes that must flow through a network of pipelines that involves the synchronization of multiple sections that connect several production fields, refineries, and ports. The planning and scheduling of transport operations of products through pipelines, oil and refined products pipelines, aqueducts, gas ducts, and mineral pipelines, is done using 3 coordinated models. Sales and operations planning, SANDOP, determines the total optimal volumes transferred during the planning periods, regardless of the sequence of products in the pipeline. Scheduling operations, SCH, determines the volumes and the sequence of batches to transfer during the planning period, whereas the volumetric planning established in the previous model. Real-time optimization, RT, determines transfer speeds, pressures discharge, and pumping stations operation patterns, to meet the scheduling of tenders. The equations in the 3 models are virtually the same. The difference is in the way the energy losses are calculated, and the operations of the pumps are handled. The integrated optimization of pipeline systems requires that all the pumping stations must be considered jointly. For real systems, it becomes a high complex mathematical problem. For this reason, it must be faced using large-scale optimization methodologies, based on the partitioning and decomposition of the problem. The transportation system has two fundamental components, the pipeline system and the pumping stations. The real-time models includes nonlinear modeling that determine the amount of energy consumed based on the flow of products in the system. In aggregated models, when multiple types of products can be transported in the pipeline, the total transport time must be divided into the time used to transport each type of product at different transfer rates. To represent the flow of energy through the transport system, the following constraints should be considered. Energy conservation in the ducts and nodes of the system. Minimum pressure limits, or compression, at the outlet of the ducts, and pressure, or compression, minimum input to the ducts, depending on the type of connection between the operational area, node, and the duct. In the real-time model, a detailed hydraulic system is available in the pump operation model, for each type of pump in the pumping system, and each link in the pipeline, for each type O product, O crude. This ensures the feasibility of the results. Drag reduction is a physical phenomenon that causes friction to be reduced, and fluid flow to be increased. Chemicals that reduce drag are known as drag-reducing agents, DRA. Several polymeric compounds can reduce the wall shear stress of flowing liquids at low concentrations. Thus, the use of DRA has the following advantages. Increased pipeline capacity, the throughput. Savings in pumping power. Pressure reduction with the associated reductions in pipe thickness, and pressure surge, and reduction in pipe diameter in the design phase, as well as the number or size of pumping facilities. Drag reduction optimization is a nonlinear optimization process. This implies the determination of the optimal amount of DRA that must be injected into the oil products to optimize its transport, considering the cost of DRA at the injection site, the change in operating conditions, and the value of saved energy. The triangle defines the possibilities of operation. For a given level of DRA, the optimal solutions will be over the yellow line. The concept of digital twin is associated with cyber-physical systems, and brings an innovation that will bring a new aspect to industrial automation. However, the basic concepts of digital twins are ancient, and date back many years when difference and finite element models were used to build industrial and natural process simulators, which serve to support decision-making, and to validate the knowledge we have of the process in question. The big change in Industry 4.0 is due to the ease of its implementation, which includes modern visualization, using virtual reality and augmented reality concepts. Natural gas supply chain optimization. Similarly, like oil, natural gas supply chain may be modeled as an optimization mathematical model to simulate the transportation and storage of natural gas. The diagram presents the natural gas supply chain. The main features are: natural gas is produced in gas wells, or as an associated product in oil and gas wells. The marketing of gas implies that it can be transported massively by means of gas pipelines, or in ships. For this it is required to turn it into liquid, in liquefaction plants, and later converted back into gas, in regasification plants. This usually happens at terminals in port. Transportation through pipelines requires gas compression stations, y. Finally, the gas is delivered to a market, usually segmented, in industrial, vehicular, residential and commercial, and thermoelectric plants. As integrated products, electricity and gas must be modeled together. As a basic energy, the natural gas is a raw material of electricity, and in turn, as useful energy, it is competition of electricity. The optimization model includes the following types of nodes. Production fields. Consumption center, natural gas demand nodes discriminated by demand sector, among which are industrial, vehicular, electricity generation, commercial, and residential, and ports and terminals that can receive and/or send LNG. It is associated with liquefaction and/or regasification plants. Similarly, like oil and LNG, liquefied petroleum gas, LPG, distribution chain may be modeled as an optimization mathematical model. Liquefied petroleum gas distribution chain optimization. A mathematical models for distribution planning and propane gas containers gathering. It is aimed at supporting the weekly and daily programming and operational rescheduling of trucks dispatch. The modeling hypotheses are as follows. Fleet of vehicles consisting of multiple type of trucks and multiple type of LPG trailers. Trucks can be moved with or without trailers. A truck can tow some type of LPG trailer. LPG trailers can be dispatched with or without charge. Vehicles move between nodes, or terminals. In the nodes there may be demands that must be met, or purchases that enter LPG into the system, and LPG storage tanks may exist in the nodes. The optimization model includes the following types of nodes. Production fields. Consumption center, natural gas demand nodes discriminated by demand sector, among which are industrial, vehicular, electricity generation, commercial, and residential, and ports and terminals that can receive or send LNG. It is associated with liquefaction or regasification plants. Financial planning in oil transportation. Integration of financial planning to the pipeline optimization model, to obtain in real time the projection of the end of the current month, or year, the budget or long-term projections of costs, financial statements, P&L, cash flow and balance sheet, and monitoring of budget execution, financial analysis, facilitating the analysis of information and the decision-making process. Solution powered by artificial intelligence, which significantly reduces the time required to carry out financial planning and analysis processes, by integrating real-time data from multiple sources collaboratively and simulating different scenarios to solve strategic business questions through self-service dashboard. Unifies and streamlines planning, budgeting, forecasting, and optimization across the organization. The objective of financial planning is to simulate the assets and liabilities management, considering the results provided by sales and operations models. It is a modeling consolidated methodology that focuses on the financial modeling of companies. The minimum financial modeling should be oriented to evaluate the NPV for a pre-established ROI, return of investments. It will provide the financial statements, balance sheet of assets, liabilities and equity, income statement, profit and loss, after tax, royalties, and other contributions, and cash flow. Numerical simulation model of the digital twin. It corresponds to the physical model that exactly reproduces the behavior of the piping and pump system, that is, the flow of different types of products in the different sections of the pipes, and of the operating conditions in the pumping stations, for each pump configuration pattern, in series and or parallel, for each type of product, for any pump speed. This model is integrated as physical model to predictive analytics methodologies, specifically the Kalman filter, and basic model to generate the approximate model that is part of the optimization models. The numerical simulation model produces matrices, or tables, that are the reference of the exact operation of the piping system and pumping stations, and these tables numerically represent functions of the energy consumed as a function of pressure, flow rate, product type, DRA injection, ambient temperature, etc. Validate and correct advanced analytics models, mainly optimization models. State estimation, models the prediction of estimation of the variables that represent the state of the system. These can be pressure, flow, RPM, roughness, density, etc., and physical model parameters, estimation of the parameters involved in the equations that represent the physical system, and which are subject to uncertainty. It is considered that the appropriate methodology is the Kalman filter, FK, including some of its variations and extensions. FK is, perhaps, the oldest, and most robust, methodology of hybrid predictive AI. The numerical simulation model can be used to generate synthetic operation samples, as it is assumed to correspond to the exact representation of the system, and thus enrich the database, Very useful in the case of young systems with few historical measurements. Prescriptive analytics. To optimize are required the following models. The operation, dispatch, of the pipeline, at least 1 or 2 days in advance. This implies a real-time operating model, whose planning horizon is divided into periods of hours, fractions, and which can be redispatched at any time, and the transport of hydrocarbons in relation to nomination, DRA dosage, energy consumption month by month. This implies a short medium-term tactical operating model, whose planning horizon is divided into periods of weeks, fortnights or months, and that it serves to adjust the pothole program, prior to the dispatch of the polyduct. It is considered that the appropriate methodology for these models is mathematical programming, Tambien conocida como exact methods. The other optimization alternatives are discarded by not be exact, may produce unfeasible solutions, and they don't guarantee to get the optimal solution, they leave money on the table. The results of the models, mainly the real-time ones, must feed the databases of the SCADA system, or distributed control. The image presents the IT architecture of the proposed solution. The mathematical models will be analyzed later. The high methodology involves linking predictive and prescriptive artificial intelligence methods, to give rise to decision-making artificial intelligence. Pipelines energy modeling. Predictive analytics models, forecasting. Based on hybrid models, model-driven plus data-driven, supported in state estimation methodologies, more specifically improvements and variations of the Kalman filter, KF. Overall, the minimum functions of these models are smoothing, filtering and forecasting of the viscosity value of the crude oil transported in real time at any point of the pipeline, taking into account that, on a daily basis, laboratory tests are carried out to establish the viscosity value that is being transported. This actual viscosity data is confirmed a day after the shot by analysts. Smoothing, filtering and forecasting of the viscosity value of products in real time, assuming that an inline viscometer is available. However, the measurement of this is not exact, but it maintains precision, and allows you to verify the trend of the measurement. Identification of the operating periods during which, due to the quality of the product, density and viscosity, the dosage applied affected the transport of hydrocarbons. Given the characteristics of KF, smoothing, filtering, and forecasting of the value of the pipeline's operating variables at any point, using the pipeline's physical model, and smoothing, filtering and forecasting of the value of pipeline parameters, e.g., roughness, slope, etc., when it is considered that these may be subject to uncertainty. As a general rule, it is considered appropriate to use an extended Kalman filter, or a dual Kalman filter, to simultaneously estimate state variables, and the parameters of the equations. Data-based algorithms only consider the database of observations, historical or synthetic, to determine the dynamic prognosis of the physical process. Normally, the related professional is a data scientist. Model-based models are based on the numerical simulation model, which must be fitted by means of algebraic expressions, to be expressed as a system of stochastic differential equations, or finite differences, or finite elements. This requires an expert in the field of interest, in this case fluid mechanics, mainly in the transport of petroleum products. The integration of the two approaches gives rise to hybrid predictive analytics, which can be considered as the appropriate method, that takes advantage of the mathematical knowledge of the physical system, and historical information. The most well-known method, and most used, for more than 65 years, is the Kalman filter. The state estimate describes the system based on state variables, characterized by discrete, empirical probability distributions, and dynamic, empirical, probability distribution functions that evolve over time. Forecasting, predictions about the future, and filtering, predictions for the present. In a system under uncertainty, correcting the past may be just as important, if not more so, than forecasting the future and estimate the present. Examples of applications of the Kalman filter in pipelines are system monitoring, parameter calibration, leak detection, and maintenance following PHM methodologies. Kalman filter applications in oil and gas pipelines. Though interested in learning about Kalman filters applications in the petroleum industry, we invite you to watch the video series Oil and Gas State Estimation Using Kalman Filter. This video discusses use cases of the Kalman filter throughout the petroleum supply chain. It is formed by the following parts: Part 1, Kalman filter framework; Part 2, oil and gas production; Part 3, oil and gas transport by pipelines. It should be noted that the applications of the Kalman filter, in the petroleum industry, are not limited to the cases presented, they cover the entire supply chain. In the case of pipelines, the main applications are estimation of the operation profile, leak detection in pipelines. Success case, China National Petroleum Corporation. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, it can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Like Herbert Simon, Hypothalamus Artificial Intelligence and Proclidad Analytics believe that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.